Hello, welcome to second semester. Excited for uh, start of official college algebra. So we're going to learn, like we talked about earlier in this course. A lot of things we do in this class are going to be uh, just reviews, deep reviews of what you've done the last 4 years. So you're looking at quadratic equations and you're like, oh yeah, I know that. Yes, you guys hopefully feel comfortable with quadratic equations, but we're just going to dive in a little bit deeper. All right, so what is a quadratic equation? It's a nonlinear function that can be written in standard form, y equals ax squared plus bx plus c. A little known thing about this, all these letters are pretty important. The c is actually the y-intercept when it's in standard form, and the a tells you if it's narrow or wide, and it also tells you if it goes up or down. It's up if it's positive, it's down if it's negative. Okay, so that's in standard form. Now, vertex form, uh, remember how we did completeness square, and some of you guys are like, well, why are we doing completeness square? We do it for this, to write things in vertex form, because the nice thing about the vertex is it tells you right there if it's in vertex form that it's h comma k, and that's the lowest or highest point of the graph. And the a here still has its same purpose. It tells you if it's narrow or wide, and it tells you if it goes up or down. Now, a parabola is a U-shaped graph of a quadratic function. It could be either U, or I guess you can call it like an N. The vertex is the lowest or highest point of the parabola, h comma k. And this is, again, sometimes in math things are counterintuitive. So you're looking at this and you're like, well, it's positive hk, and here you notice, well, it's x minus h, but it's still a positive k here. So, if it's in the parentheses, it's going to be the opposite. Especially, you saw that with circles. It was x minus h squared plus y minus k squared, yet the center of the circle, which h comma k. This is going to be very typical when you have things that are applying to the x in particular, but if they're on the same side of the equal sign, then it will be applied to the y as well. So the lowest or highest point of the parabola, and k is the maximum or minimum. The axis of symmetry is this imaginary line that divides a parabola in half. It's a vertical equation or vertical line, x equals h. And what's nice about it is once you get this x equals h, or the axis of symmetry, you already know the x value of the vertex. And so all you need to do is substitute it in to find the y value. Nice thing about the domain, it's pretty easy peasy. It's all real numbers. You don't have to worry about that. And now for the range, this is also not too bad once you find the vertex, because if it is a minimum vertex, that means that the graph opens up like this, and it goes from k with a bracket, so make that adjustment here, the bracket, and then k to infinity. And if it is a maximum vertex, it looks something like this. Okay, and there's your vertex, and it's negative infinity to k, again in a bracket, so please make that adjustment there. All right, so now let's go ahead and try some of these problems. Use a quadratic equation, y equals 1/2 times the quantity x minus 3 squared minus 6 to complete the equations below. First of all, recognize that it's vertex form, so that's nice. And second thing to recognize is what's the vertex. You'll be able to pick that out instantly. So remember, it's the opposite of h comma k, so the vertex is positive 3 comma negative 6. All right, so now as a graph open up or down, and that's what this all valuable a value tells us. Since the a value is positive, it opens up. What is the vertex? Well, we already got that, 3 comma negative 6. What is the axis of symmetry? Remember, it's just the same as the x value of the vertex, so that's x equals 3. And now sketch the parabola. So I know that you guys could easily plot 3 comma negative 6, and you can easily do the axis of symmetry, but please make sure you fill out a table and to graph the rest. Don't just like do some like, oh, there it is. No, I'm not going to accept that. You guys know, you guys are better than that. So let's go ahead and actually plot the points. And honestly, I just want you guys to use your calculator. Go ahead and throw this equation in your calculator. Just make sure to put your vertex in the center here. So this is 3 comma negative 6, and just go 2 up and 2 down from there. So all I'm doing is using my calculator. Okay, so 2, 1, 4, 5. So when it's 2, it's going to be negative 5.5. When it's 1, it's going to be negative 4. When it's 4, it's going to be negative 5.5. There's your symmetry. And when it's 5, it's going to be negative 4. So let's go ahead and plot these points here. So 1 is negative 4. 2 is negative 5.5, 4 is negative 5.5, and 5 is negative 4. All right, so now go ahead and we just need those 5 points, including the vertex, and we got a graph that looks something like this. Now, what is the y-intercept? Okay, well, if I can't tell right away on my graph, I could easily just substitute 0 in for x. The nice thing about using your calculator is I can easily go to the graph and it's 0 comma negative 1.5. But that's the same thing as if you were to say y is equal to 1/2 times 0 minus 3 squared minus 6. Substitute that in your calculator and you get negative 1.5. Now the x-intercepts are a little bit more work. You can't always tell by looking at the graph. You can't look at this graph and say like, oh yeah, it's right here and here, and don't you dare say there's no x-intercepts. It's clearly crossing the x-axis. So how do we find the x-intercepts? Well, we know one universal truth is that x-intercepts, they all have a y value of 0. So 0 is equal to 1/2 times x minus 3 squared minus 6. And now it's just a solve for x problem. So I'm going to add 6 to both sides. 6 is equal to 1/2 times x minus 3 squared. I'm going to multiply both sides by 2 to isolate the 1/2, isolate the x term and get rid of the 1/2. So now 12 is equal to x minus 3 squared. I'm going to take the square root of both sides. So I'm trying to isolate that x term. Okay, so plus or minus, don't forget that. So now x minus 3 is equal to plus or minus the square root of 12. I'm going to add 3 to both sides to get x by itself. So x is equal to 3 plus or minus the square root of 12. And I'm going to simplify this root 12. So x is equal to 3 plus or minus 2 root 3. Now, as a coordinate, and this is what you got to be careful with Math Excel, as a coordinate, you got to write it as 3 plus 2 root 3, comma 0, and 3 minus 2 root 3, comma 0. There's no way you're going to get that answer just by looking at the graph. You're like, that looks like about 3 plus 2 root 3. That's just not going to happen. So we could do it by hand and get the results. Okay, so I mean, we'll be totally happy if you give us this. Math Excel may want that. What is the domain? Again, for all of these, you just go ahead and fill it in with negative infinity to infinity. Now the range, okay, well, remember, this is the lowest point. Range is the y values. So the smallest y value that we have is bracket negative 6. And the largest y value we have, well, these things are pointing up to infinity, so it goes negative 6 to infinity. Where is fx increasing? Where is it decreasing? So these are back, the increasing, decreasing questions. Well, it's increasing or going up. These are x values. So anytime they ask for increasing or decreasing. So the x value it's going up from, well, it starts at 3 and it goes up to, or to the right, to infinity. So as x is going up, remember it's going to the right, and it's going all the way to positive infinity. Whereas it decreasing, well, it's starting from the left. It starts to decrease from negative infinity to 3. And I always use parentheses here for decreasing and increasing because at that specific point it is neither increasing nor decreasing, so that's why I can't just put a bracket there. Alright, so locating the vertex without completing a square, that's no fun. We like to complete a square, but there's another way of doing it. So given a quadratic equation in standard form, f of x is equal to ax squared plus bx plus c, the vertex can be calculated by, now this is very college algebra lingo. So let me translate this for you. First of all, you got to know this. And I know sometimes you guys, are nice and you're like, can we use our notes? Yes, you guys can for sure use your notes. You're at home, right? So you can use your notes. So it's okay. And I really appreciate you guys asking, but for sure you can use your notes. So x is equal to negative b over 2a. That is the formula for finding the x part of the vertex. It's also the formula for the axis of symmetry. Okay, so it does two jobs. Now this thing, what all that's saying is a fancy way of saying substitute negative b over 2a for x and solve for y. That's all it's saying. But we, in math, we're not going to write all that out. We're going to write it in in math lingo, and that's what that math lingo means. So let's go ahead and apply this. So y equals negative x squared minus 4x. Well, remember, in standard form, it's y is equal to ax squared plus bx plus c. So what we have to do is identify the a value and the b value. Okay, we don't need the c value right now, but we definitely need the a and the b. So the a value is -1, the b value is -4, and now I use my formula. X is equal to the opposite of b, so minus b or negative b, so opposite of -4, all over 2 times a, so 2 times -1. So that's 4 over -2, which is -2. Okay, so that is the x part of my vertex, right? So does the graph open up or down? This -8 tells me that it opens down. Down, spelled down wrong. A equals -1. What is the vertex? Well, actually the first question should be, what is the axis of symmetry? And that's x equals -2. And again, I'm okay with this, and obviously you're at home, you could do this. Once you identify the x part of your vertex, just go ahead and use your graphing calculator and use a table feature and find the rest of the values. I mean, you could certainly do this by hand. I'm not saying don't do it by hand if you want to do it by hand, but I'm saying you have this graphic calculator, you know how to multiply and add. I'm not worried about that. What I am worried is to make sure that you guys understand how to find how to plot points and how to understand the symmetry going on. So once you have the x part of your vertex, okay, go ahead and put that in the middle. Go to your graphic calculator. You can fill out the rest, so -2, -4, or -2, 4. You could certainly do this by hand. I'm not saying not to do it by hand. So y is equal to the opposite of -2 squared minus 4 times -2. Y is equal to -4 plus 8, which is 4. So that's by hand. But when you have your graphic calculator, you could easily fill out the rest of it. So using symmetry, I'm going to go 2 down, 2 up, and fill in the table. So that's 0, -3 is +3, 4, 3, 0. And we get a nice surprise, because not only do we have the x-intercept, we also have the y-intercept, we also have the x-intercepts, okay, and it's right here and here. So now let's go ahead and sketch it. -2, 4, 1, 2, 3, 4, -3, 3, -3, 3, -1, 3, and then -4, 0, and 0, 0. Okay, there's my almost U shape. What is the y-intercept? 0, 0. What are the x-intercepts? There's going to be times when there's not x-intercepts. But please, I've had students do this before. They see the graph, they see it's clearly crossing the x-axis, and then sometimes they tell me there's none. No, there's none. Look at it. It's crossing the x-axis. There's 2 of them. So what are they? Well, they're -4, 0, and 0, 0. What is the domain? That's always going to be -infinity to infinity. What is the range? Well, look. Here is the highest point. It's not going to get any higher than that. Okay, but what is the lowest point? Well, these arrows are pointing down to -infinity. So -infinity to the y value is 4, bracket. Where is f of x increasing? Again, these are x values. So where is it increasing? Well, it's starting from the left, going to the right. It's going up from -infinity to -2. Whoops. And going down from -2 to +infinity, because it's going off to the right. Okay. All right. So now, okay, we normally spend 2 days on this topic, just because there's a lot. So I'm giving you the notes right now. We're already 14 minutes in. I want to respect your time, so you can either just pause the video and come back and finish it again, or just watch it all in one sitting. Okay. So finding the quadratic function given the vertex and any point in the graph. This is kind of like write the equation of a line given 2 points. However, in order for it to work with a quadratic, you need the vertex, right? You can't just pick any 2 points on the parabola and say like, well, I'm gonna find it, because otherwise you could end up with a line. So you want to use specifically the vertex and 2 points. So first, we're going to substitute the point xy and the vertex hk into vertex form, y equals a times x minus h squared plus k. And then the only variable you're going to have once you substitute those in is a. So solve for a, and then you're going to substitute a and the vertex into the form and write f of x is equal to a times x minus h squared plus k. Now, I've had students in the past who, they'll put all the numbers in. They'll be like, well, I got this number, I'm going to use it. You can't have an equation when you don't have those variables, right? So you need either y or f of x, and you need x. So when we substitute it back in, we're just putting in the a, the h, and the k. All right, so let's get a feel for this. So the first one here, the vertex is 2, 1. So this is my h and this is my k. And this is just some points. It doesn't have to be on the y-axis. It could be anywhere. But this is x and this is y. So let's go ahead and substitute. Okay, so we're going to use y is equal to a times x minus h squared plus k. And I'm going to go ahead and substitute 5 in for y. A, I don't know. X is 0. K, h is 2. And k is 1. So I'm going to carefully simplify here. So this is 4 plus 1. So 5 is equal to 4a plus 1. Subtract 1 from both sides. 4 is equal to 4a. Divide by 4. A is equal to 1. All right, but remember, we're not done yet. We have to substitute it back into the equation. So either using f of x or y, it's not a big deal if you interchange those. F of x is equal to 1 times x minus 2 squared plus 1, or it's more commonly you don't put that 1 there, right? So x minus 2 squared plus 1. Okay, so normally in class I would say, okay, pause the video or try this one on your own. So we're on an honor system here, so you can either try it on your own, pause it, or you can watch me do it. The vertex, again, is h and k. This point is x and y. And my formula is already written for us. So 5 is equal to a times 3 minus 1 squared plus negative 3. Okay, so 5 is equal to 3 minus 2. 1 is 2. 2 squared is 4. So that's 4a minus 3. Go ahead and add 3 to both sides here. 8 is equal to 4a. Divide by 4. A is equal to 2. All right, we're not done yet. We got to substitute it back in. So this time I'll do y. Y is equal to 2 times x minus 1 squared minus 3. Okay. All right, so this is kind of a cool problem, and they use some new vocabulary. So we're given two equations. F of x is equal to x minus 3 and x squared minus 9. That's g of x. Sorry, that didn't print. Complete the questions below. So graph f and g on the same Cartesian plane. The Cartesian plane is just the xy plane. That's the fancy name for it because Descartes discovered it. So now, first f of x minus 3, I'll do this in green. So negative 3 is my y-intercept. My slope is 1, so up 1 over 1, up 1 over 1. And I'm writing multiple dots here because I want this to be really accurate because I got to find where they intersect. Okay, so there's my connected dots. This is f of x equals x minus 3. So I'll do the other one in maroon here. So x squared minus 9. So negative 9 is my y-intercept. X squared, there's a pattern that these follow, up 1 over 1, over 1, up 3, over 1, up 5. Okay, and here's what this one looks like. Okay, so now solve f of x equals g of x. Well, there's two ways you could do this. If you were really careful with your graph, first here, shade the region for where f of x is greater than g of x. That is the region below f and above g. That's right here. Okay, next question. solve f of x equals g of x. If you were really careful, you could do this two ways. So I was trying to be really careful, I was trying to be neat, and I looked right here. Where they equal is where they intersect. So since I was really neat, I could look at this and I could say, well, right here, x equals -2, and over here, x equals 0. Okay, so, or sorry, x equals 3. So that's two ways of doing it. The more common or instinctual way of doing it is just go ahead and set them equal to each other. So x minus 3 is equal to x squared minus 9, and it's a quadratic because of this x squared, so I'm going to get everything on one side and set it equal to 0. So x squared minus x minus 6 is equal to 0. And now I factor this. That's going to be two numbers whose product is -6, whose sum is -1. So that's x minus 3 and x plus 2 equals 0. And then solve for each one for x. So x minus 3 equals 0 and x plus 2 equals 0. X equals 3, x equals -2. So again, another way of getting the right answer. And the points of intersection of the graph are over here. I already got them. -2, -5, and 3, 0. Okay. All right. And now the last thing here. Some real life applications. These are just kind of neat. And you know, if you're a physics person, then this hopefully will make a good connection. The quadratic equation below gives the height of a ball in x seconds after it has been thrown up with initial velocity of 64 feet per second. When will the ball reach its maximum height? And what is the maximum height? So the when is the x and the what is the y. And the maximum height, every time now from now on, when you see the words maximum and minimum, those are going to be code words for the vertex, right? So they're actually telling you to find the vertex. Because there is a way to do this by putting in your graphic calculator and then playing with the window and then, you know, trying to do it that way, but not everyone is very tech savvy, so you can't always do that. So x represents the time and f of x, or the y, represents the height. Or f of x, the actual function, is the height. Spell height, right? No, I before e. All right. All right, so now find the vertex without completing the square. All right, good, because this would be a tough one to complete the square on. So how do you find it without completing the square? We got to use x equals -b over 2a. That formula works so well, it's way easier than completing the square. So all I have to do is identify my a, my b. Here's my c. I don't really need it right now. And so x equals -b over 2a. So that's going to be x is equal to the opposite of 64 all over 2 times -16. X is equal to, that's -64 over -32. X is equal to 2. So after 2 seconds, the ball reaches the maximum height of, so now we're going to take that 2 and I'm going to substitute it in to find the maximum height. So now f of 2, function notation that tells me I'm using 2, is equal to -16 times 2 squared plus 64 times 2 plus 100. Put it all in the calculator and we get a maximum height of 164 feet. And now the last thing here. Suppose a t-shirt manufacturer has found out when the unit price is $P, the revenue is R. So R of P is equal to -2P squared plus 40P. What should the unit price be to maximize revenue? Okay, again, here's that word maximize. If you're just coming to our classroom without any experience whatsoever, you might be scratching your head saying, how do you maximize? But we know better now. We know that when they say maximize, they're just talking about the vertex. It's no secret. So what is the maximum value? Well, this is my A, and this is my B. So I'm going to use x is equal to -b over 2a. So in this case, P is equal to -b over 2a. So now the opposite of 40 over 2 times negative 2. So that's negative 40 over negative 4, which is 10. So you should charge $10 to maximize revenue. And what is the maximum revenue? All I do is I substitute it back in. So that's revenue based on a price of $10. R of 10 is equal to negative 2 times 10 squared plus 40 times 10. Put it all in your calculator and you get $200. Okay. All right. So looking forward to seeing you guys in person on Tuesday, and looking forward to a great semester. See ya.